Hi there. In this lesson, we'll talk about variables, and I'll tell you how to create fields that will be displayed in the inspector, and how to change the properties of different components from the script. When programming, we always work with data. We take data, perform various operations with it, modify it, and display it on the screen. Data is stored in variables and can be of different types. Different data types are needed to describe different values. For example, the number of coins is an integer 50, 170 coins, but not 10.5 coins. It is convenient to represent a person's height as a float. For example, my height is 1.78 meters. Data is not just numbers. For example, the name of the city are strings. There are also more complex data types, such as color or vector 3. Vector 3 is a parameter of 3 numbers convenient for setting the position of an object in 3D space. Let's go to Unity and see how variables are created and how to work with them. We have already seen variables of different types related to objects in the inspector. For example, a light source, which has intensity or color. Intensity is a float-type number, an ordinary decimal number, but the color is a specific data type, so you can set the color in it. There are some parameters that are set by checkboxes, for example. Like this one, right? Or, for example, we have a capsule here, which has mesh renderer. These are Boolean data types. They can be either true or false, but this is a property. Some properties are set by drop-down lists like this, and some by links to objects. The material that is on this capsule is a specific data type, but it is a link to the materials of the scene, more precisely, from the project. In this lesson, we will also talk about how to create fields like this in the inspector, and how to work with them. I have created a new empty test script. I apply it to this capsule now and display a certain number of parameters with different types in the inspector. I add them from the clipboard here. These parameters are like properties of our class. They are called class fields. And here I have created several types of these fields, such as height. They don't do anything yet, but later we will give them a value. So, the height is a float type, a decimal number. For example, the number of coins is an integer, while the name is a string type. Its color is of the color type. Here is start position. Its value is of the vector 3 type, and there is a Boolean data type, which is indicated by a check mark, which means either true or false. Let's take a closer look at what I wrote here. At the beginning is the word private, an access modifier. There are 2 access modifiers, private or public. Private means that we can access this field only from this script, and public means that we can also access it from other scripts. Later we will have examples of how it works and it will be more understandable. For now, let's make all the fields private until we need to access them from somewhere else. Class fields are variables that we can work with and equate different values to them, and they can change during the script operation. There is another thing to display these fields in the inspector, but as we saw with the light source and all that, you need to add another attribute here. In square brackets like this, the serialized field attribute is written. It literally means that this field will be displayed in the inspector. Sometimes we don't want the field to be displayed in the inspector, it would just be redundant. Such fields don't need an attribute, but we will often add it. Now you can save it all and see what it looks like in Unity. I've applied a script to the capsule, and all these fields are displayed here. The height, the number of coins, you can enter a name, change the color, but so far these are just fields, they do nothing, mean nothing. You can just set some values in them. Now let's make these values apply somewhere, and change something in our scene. I won't take up your time, I will write this code and we will go through it. There are some things here that we haven't discussed yet. In this line, I think everything is more or less clear. We take the transform of this object, the transform of our capsule, and set its scale. Along x and z it will be 1, and in height, the scale will be equal to the height parameter, which we will set in the inspector. Then, we change the name of the object, GameObject name. Before, we just wrote this word in quotation marks. Some name can be written this way, but since our parameter has the string type, it is a string, so we can equate the name to the string that is stored in this variable. Then there's this construction, getComponentRendererMaterialColor. Here, we assign a color to the material of our object. We will often use the getComponent method. What is it doing? It takes a component from this object. There is a mesh renderer component on our object, with a script on it. This is how we access it. We take a component from the object here, it is called mesh renderer, here I wrote renderer. But as a rule, in fact, our components will be written exactly the same as they are named. If you're not doing a deep dive into the details, then you can write mesh renderer here. Okay, these are just details. Then we enter this component and start accessing the parameters it has. The mesh renderer component has a material. We access the material, then its color, and change the color. So far, it looks frightening. It will be enough just to remember that this line is needed to change the color of the object. This is already good and useful knowledge. Then, we assign the position of the object. Here, everything is simple as well. We equate the position to the vector. In the last video, we used setActive. I said that you can write true or false here, but we wrote false to disable the object. But we can also pass some Boolean type value here, and in fact, setActive will be equal to this value. That is, it will be enabled or disabled depending on the value of this check mark. Let's save the script and see what happens. I wrote this code into the start, so it will be executed as soon as we launch the game. Let's change some parameters. Let's say the height of this object is 3 meters. I haven't assigned the number of coins to anything. It doesn't do anything in our code. Let its name be player. Then, we set some color. Let the start position go up 3 meters. We will also make it alive and true so that it is not disabled. Let's launch it. And now, all the changes have happened. So, that's how it works. You create variables of different types in the field code, then you assign them in the inspector in the form of code, what exactly they should mean, and how it will all work. When the game is running, if I change something, it will not affect the objects in any way, because we just wrote this code into the start. If you transfer all the same things to the update, then when you change things in play mode, everything will automatically change. Here's another thing I wanted to show you. What if we want to access an object from this script and change its properties? For example, say you want to make this light source turn red. Here's how to do it, not with your hands, but from the code. We need to access this light source in some way. One way is to create a script that will be on this source, and then use the getComponentLight method to access it. But what if I want to access the light source from the same test script that is on the capsule right now? To do this, you can create a field into which you will place this light source. I'm writing serialize field so that this field is displayed in the inspector. Then private, then light, as well as the name of the component. It should be named. Let's name it sun. Now, this variable will mean this particular sun. We still need to place it here now. Save the script. In our capsule, there is a special field in which you can place the light component. It is written in brackets here. Take it and transfer this sun here. Now, when we use the word sun in our script, it means something that is located in this field. And you can do something interesting. For example, let's write Sunday and see what parameters sun has. We've seen that it has intensity, right? Let's write intensity equals 2, for example. It also has the color, Sunday color equals. There are some ready-made colors, by the way. For example, you can just write color.red. It's going to be red, right? Also, if you write a dot, you can see what other standard colors there are: green, black, blue. But we can assign this color here body color. And that's it, it will work in the start, and the color will change. This line turns out not to make sense because we sort of assign it at the beginning, immediately followed by another one. So I would like you to understand very well that we can have links to different objects, scenes, and components in the script. Let's repeat it again. We will change a camera parameter. I will create a variable that will have the camera type. Again, just like the name of the component. You can name it camera in the same way, just with an underscore. By the way, I will explain why I write this underscore everywhere at the beginning. We can also access it. Yes. Camera. The camera has a field of view that equals 120. Save it and go to Unity. A field for the camera appeared in the script. Drag it there and launch to see what happens at the start. That's great. Look, the camera looks very strange now because it has a field view of 120 degrees, and the light source has intensity and color. Everything has changed to what we wrote in the script. Finally, I also want to show that transform is exactly the same component. We can also access it and create fields for it. Say I want an object to be above our capsule all the time. For example, this sphere, let it be above the capsule all the time. To do this, we need to create a variable for it in the script, in which it will be stored. Since I want to move it after the capsule, I need its transform component. Therefore, we create a field that has transform, and call it something like ball. I want it to be triggered every frame, so that it moves after it all the time, so we'll write ball.position in the update, right? Now we are accessing transform of this ball through this variable. Let's say we take the position of our object on which the script is and transform position. If it has to be above it, then add 3 meters up to it. That's how the vector rises 3 meters above the position of this object. I select the capsule again. Now it has a field in which you can place any transform. But here is a sphere, click play. What will happen? Not too impressive, but I think we should be impressed that we can now influence all the parameters of all components, accessing their properties from the script. We can also place some other object here, but instead of a sphere, let's place a floor plane here. For example, the floor is now moving behind it. Everything in this field that we have written in the script is applied to this object. Let's go through the important points of the lesson again. This is what we will face in any script. There are public and private access modifiers. Public enables you to access the field from other scripts, while you can work with a private field only inside this script. To display a private field in the inspector, the serialize field attribute is used. The getComponent method enables you to access the component from the object on which this script is. Let me remind you that it is important to practice. Think of small tasks for yourself within the framework of what we have studied. I think that the ability to come up with such tasks is the most important skill in learning programming.